Chapter 1, Section 2 is classifying numbers and simplifying radicals. Square root, I know I'm going to the second one first, is like this. That's the square root sign. With radicals, you can actually have square roots and cube roots and fourth roots, and that all comes later in Algebra 2. For right now, we're just going to do square roots. And with square roots, our perfect squares, we're just going to list them. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. So we're going to use that to do these square roots. Square root of 49 is saying what number times itself equals 49, and that will be 7. Square root of 36, what number times itself equals 36, will be 6. Square root of 9 is 3, and then you have to put the negative in front of it. Number 4, we just break this up into parts. Square root of 49 is 7. Square root of 81 is 9. Number 5, you have this negative underneath the square root sign. There's no number times itself that equals a negative. So this one is not possible or empty set. Square root of 25 is 5, and then when you put the negative in front of it, that becomes negative 5. We have these 5 different sets of numbers that we're going to talk about. The first ones are the natural numbers, or sometimes called counting numbers. So you just start counting with 1, 2, 3, 4, 5, 6. Those are your counting numbers or natural numbers. Whole numbers are all of those, but you also include 0. So the natural numbers, or whole numbers, include 0. Integers are positive and negative whole numbers. So I'm going to start negative 3, negative 2, negative 1, 0, 1, 2, 3. So integers are basically no fractions. Rational number is any number that can be written as a fraction. So it includes whole numbers like 5, negative numbers like negative 5, fractions, repeating decimals, like if you have square root of 4, which is a whole number, that would be rational. Irrational numbers, there are only 2 types of irrational numbers. An irrational number cannot be written as a fraction, and our only 2 irrational numbers are pi or square root of a non-perfect square, like square root of 2, square root of 3, square root of 4 is a whole number, so that's rational. Square root of 5 would be irrational. In example 2, we want to give all classifications here. Negative 32, it's not a natural, it's not a whole. It is an integer, and we use z to stand for integer, and I cross my z's like that so they don't get mixed up with 2's. And negative 32 is also a rational number, which is q. 7 4/9. It's not whole, natural, whole, or integer. Whenever there's fractions or pieces, it's only going to be a rational number. That means negative 2/3 is also a rational number. Square root of 10. Look at your chart. It's going to be irrational. Number 5 kind of needs to be simplified first. Square root of 64 is 8. So that number is actually a 16. And that falls into 4 categories. It's a natural number, it's a whole number, it's an integer, and it's irrational. 0 is kind of a special case. 0 is a whole number, it's an integer, and again we're going to use z, and it's also irrational. 2.75, you've got these fractions or these pieces, so that is a rational number, which is q. 4.6 repeating is a rational number. Square root of 7, there's no number times itself, which equals 7, so that is irrational. And pi is one of our special cases that's also irrational. And here's kind of a chart, shows your natural numbers, whole numbers, integers include the negatives, and then rational include anything with fractions. And with irrationals, I'm also going to write pi here and square root of 3. Example 3 says, what type of numbers or solution set would make the most sense? So if we're talking points in a basketball game, can you have negative points? Not really. You can't have a half a point. It is possible to have 0 points. So for my solution set here, I would say it would be whole numbers. Temperature, you can have a temperature that goes down. You can have a temperature go down half a degree. So negative and fractions would make sense. So that would be rational. Tuition at college, you can have fractions. You cannot have any negatives. So for this one, I would say positive rational. Students in a room, either you're in a room or you're not, can't have any fractions. So you can have 0 students. So I would use whole right here. Money in your bank account, you can have fractions, and you can be overdrawn, so that would be rational, which is Q. Cans of pop that you can drink, you can drink 2.5 cans, so that would be rational. Cans of pop that you can buy, you can't put in 50 cents and only get half a can of pop, so that would be whole numbers. Reminder on vocabulary here, rational numbers can be written as a fraction. Rational can be written as a fraction. Irrational cannot be written as a fraction. And perfect squares, again, are 4, 9, 16, 25, 36, 49, 64, 81, and 100. and I'm only going to go up to 100 this time. And at the top of our next page, we have two different ways to simplify a perfect square. The second way I'm going to do first is breaking apart with perfect squares. Basically, you need to find a perfect square that can divide into 60, which is 4 times 15. And those are both underneath the square root sign. So square root of 4 is 2. And now that's outside of the square root sign. And the 15 stays underneath. Now, not everybody can look at that and say this is how you can divide that by 4. And the other way is the factor tree, and this is what we're going to do more. Let's say you broke that into 6 times 10. And then you broke that into 3 times 2. And you broke that into 2 times 5. And I'm going to cross out those numbers that we broke up. Now this is all still underneath the square root sign. And these pairs can come outside, which is 2. And then underneath the square root sign, you still have a 3 and a 5. So 2 square root of 15. And you'll notice we have a couple more examples here. 8, I'm going to break that into a 4 times 2. The 4, I'm going to break into a 2 times 2. And then I'm going to cross that 4 out. And then I still have that 2 left. See how I have that 1 pair of 2's? That comes outside of the square root sign. So that's outside of the square root. This is still underneath the square root. 75, probably going to break that into a 25 times 3. The 25 we can break down into a 5 times 5. I'm going to cross that out. And you have this 1 pair. Whenever you have a pair, it comes outside the square root sign. So 5 square root of 3. 32, I'm guessing most of you would probably break that into a 4 times 8. We can break the 4 into a 2 times 2. We can break the 8 into a 4 times 2. And then this 4 can be broken down again into a 2 times 2. So we keep breaking it down. We have this pair of 2's and this pair of 2's. So you have 2 2's in front of the square root sign and 1 2 underneath the square root sign. 2 times 2 is 4, and then square root of 2. Letter D, 20. I'm going to break it up into 2 times 10. And then that 10 I can break down into a 5 times 2. We have this pair underneath the square root sign, so that becomes 2 square root of 5. Letter E, 24, I'm going to break down into a 4 times 6. And if you picked 3 and 8, you should end up with the same answer. You will end up with the same answer as long as you do your math correctly. So the 4 breaks down into the 2 times 2. 6 breaks down into the 2 times 3. Since these two are a pair, that comes outside the square root sign, and these 2 times 3, stay under the square root sign. Letter F, 150. Change into a 15 times 10. 15, I'm going to change into a 5 times 3. And the 10 becomes 5 times 2. Here's a pair, so those come outside the square root sign, and 3 times 2 is 6. Now, whenever you have a multiple of 100, there's kind of a trick you can do. If you break that up into 100 times 3, think about the 100. You can break that up into the 10 times 10. And then you have this pair, and that becomes 10 square root of 3. 125. If you don't know, that's 25 times 5. The 25 can be broken down into the 5 times 5. We have one pair, so that comes outside. And then you have 5 square root of 5. 500, it's another multiple of 100. So I'm going to break that into a 100 times 5. 100, I change into a 10 times 10, and that becomes 10 square root of 5. Letter J, 12. I'm going to break it down into a 4 times 3. The 4 I'm going to change into a 2 times 2. And then here I have these pairs, so you end up with 2 square root of 3. 50, I'm going to break down into a 5 times 10. The 10, I'm going to break down into the 5 times 2. And then we have a pair of 5s here. So that comes outside the square root sign, and you have 5 square root of 2. 28, if nothing else, divide it in half. 2 times 14. 14 becomes a 7 times 2. And you have this pair, so that comes outside, and you end up with 2 square root of 7.